All right, 3.5. Pardon the hair change. This is a different year that I'm recording this video than all the other ones. So we're talking about arithmetic sequences and linear functions and all of those things. It's going to be great. So, what is an arithmetic sequence? Well, an arithmetic sequence is a sequence. So, a sequence is, like numbers, a list of numbers in this context, or quantities, or whatever else. So, it's a sequence that has a common difference. Common difference. So, let's explain what we mean by that with a couple of examples. One that is and one that isn't an arithmetic sequence. Difference. Okay, so we've got a couple of sequences here. Which one is arithmetic and which one is not? So let's start with number one. So this one, to get from here to the next one, what do we have to do? -4 plus what, or minus what, or whatever else is -2. Well, -4 plus 2 is -2, and -2 plus 2 is 0. 0 plus 2. So this one is an arithmetic sequence. This one is arithmetic. Arithmetic, right? This one is, which means this one isn't. Let's take a look at this one. So to get from 1/2 to 5/8, what do we got to do? Well, we got to think about that in eighths. So this would be 4/8, right? So to get from 1/2 to 5/8, we would add 1/8 plus 1/8. To get from 5/8 to 3/4, again, we got to get this into eighths. So this would be 6/8. This is looking good, right? We like that. There's bound to be a twist, right? Because I said, well, I already gave it away. One of these is and one of these isn't. So unless we did something wrong up here, this is the isn't, right? So, but to get from 5/8 to 6/8, we add 1/8. This is just kind of an aside for the future, for your homework, for those kind of things. It doesn't always have to be plus. We could also be going down. It could be minus as well. That's also possible. So to get from 3/4 to 13/16, we got to convert this to sixteenths. Now, so that would be, multiply these times 2. So that would be what? It'd be 12/16. So to go from 12/16 to 13/16, we're actually adding 1/16. So see, it doesn't have a common or the same difference all the way through. So this is not arithmetic, right? And so that's what we're talking about when we're talking about that was just too big. I thought I could finesse it, but not any such luck. This is not arithmetic. Arithmetic. Right? So that's what an arithmetic sequence is. Let's look at an example of kind of what a typical problem in this topic would actually look like. Because as and one type of problem would be like what we just saw, and that is there we go. It would be something kind of like what we just saw. I mean, that would be a thing, right? You might be asked, is this sequence arithmetic or not? Yes or no. So that is one type of problem, but an even more common type of problem is something like this, where we're given a sequence and we're supposed to write an equation for the nth term in the sequence. Now, if you look at our textbook, it'll give you, and other places, you might look this up online, and there's kind of a formula for these that kind of always works and whatever else. I kind of teach it more procedurally, and so if you want to find an equation, you can look in our textbook or you can look online for an equations, but we're going to kind of do this a little bit more procedurally. You'll see what we mean. Okay, so first let's make sure this is arithmetic. So to get from -12 to -8, we're going to add 4, -8 to -4, adding 4. Again, this doesn't always have to be plus. It just happens to be in these examples. I should have maybe switched this example. I don't know. It's fine. But we're also going to add 4 to get to 0, right? So that's kind of the first step in writing an equation, is figuring out what that difference is. That difference ultimately is going to be multiplied, right? So this one is multiplied. The yellow is multiply. This is times. Now, we need to figure out whether there is anything added in this equation. We're writing a linear equation, which we'll talk a lot more about in our next lesson, but we're writing a linear equation, so usually there's something multiplied, and potentially added. We'll remind us in the next lesson, and we've already talked about this a little bit, but you'll get one of those. The one that's multiplied is that slope, and then the other one is the y-intercept, right? And so we've kind of already seen some review of that, and we'll see even more in the next chapter as well. But we need to figure out whether we're going to add anything. This part is going to be multiplied. Don't worry, I am going to write this down so you can see what I'm talking about. We need to figure out if we're going to either add or subtract anything. And so what we need to do is we need to figure out what the 0th term is. And let me put a little bit more stuff on here so we can see what I mean. So this in our sequence is the first term in the sequence, which makes this the second, this the third, this the fourth. The fifth would be positive 4, right? We would add 4 to get to the next one. We keep on going, keep on going, keep on going. But we need to know what the 0 term is. So we need to walk one back and figure out what that 0 term is going to be. Okay, so we got to do the opposite of this. So we're adding 4 to get to the next one. So to go backwards, we would subtract 4, right? So negative 12 minus 4 is negative 16. Okay, so this one, and I'll do it real cautiously, this one is added. Okay, so now let's actually write out the equation as an answer. Write out the answer to maybe part A of this question. So for writing the equation, we're gonna label the value of the term A sub n. That we're gonna borrow from the book as well. In our next chapter, we'll probably be using y for this and x for the other variable. But A sub n is more descriptive. So the value of the nth term. And then we're going to multiply the yellow one, the common difference. So 4 times, we're going to use n for the number of the term. So like n in this first one will be 1. If we put 1 in here, whatever else. And then we're going to put this one at the end. So minus 16. So there is the equation. So like to use this the normal way, and we're going to do this with this one here in a minute, to use this the normal way, we put the number of the term. So like if we wanted to find negative 12, you'd put 1 in there. So 4 times 1 minus 16 equals negative 12. You can check it on your calculator or do the math yourself or whatever else, right? And so you put the number of the term in for n, and it gives you the value of the term. So the number of the term versus the value of the term. So you probably will have a part B to this type of problem, and that's find the blank term in the sequence. Now, on your homework, you'll find things where you're expected to find the 9th term or the 10th term or something small, right? Sometimes. And I don't do that on quizzes or tests because, like, say this problem said, find the 6th term. Well, we just add 4 and then add 4 again and get 8 as the answer. And that is too easy to brute force, and you don't have to have the equation to do it. This, if we go with something like the 203rd or the 1024th or whatever term in the sequence, then it kind of forces you to use the equation. We could do this, and we could add and keep on going 200 some odd times and finally get to the answer. But if we use the equation, it's going to be a lot easier. So if we just found the equation in part A, if you will, and so we're going to use that to find the 203rd. So the value of the term is 4 times, and then we're going to substitute the 203 in there. We use that property a lot, right? That substitution property where we're going to substitute something in where it goes. So 4 times 203 is